Right. I'm Ganesh Visuddha. I'll be this. And a lot of stuff has been done in the last 3 classes, which you have learned on. Maybe you can review with someone you can ask. For the sake of how can we not repeat it. How you guys? Is good. Only one person must back. I'm alive now. Being alive is good. Problem will not whatever you guys do in life, excel at it. Okay? If you're simply going to do what everybody else is doing, then there's no difference between you and somebody else and the point. Whatever you do, or see that. So whatever you do in life, you must excel. If you become an engineer, be the best engineer that can be. The company should be after you, they should offer you money. Okay? If you're a scientist, the lab should come to you and they should say, come, we'll give you more money. If you're a student, be so good that the college should say, we'll give you a scholarship, your education will be free, please study with us. Okay? Is that fine? And everything, are you sick or something? Little bit. Take it. See, what differentiates you from the best is only 10%. Okay, the difference between you and somebody else who is the best is that way only you 10% more. Okay. And the thing is, 90% of the people they have the same knowledge. Because that on the top guy, he has put in 10% more effort to understand it better, to do it better than the rest. Okay. That's the only difference in my life that I have seen. In this laptop, I'm on a scholarship. And I didn't pay for this laptop, I got it as a scholarship. The laptop costs about 1.5 lakhs. It's an Indian laptop. People got into gaming. I didn't pay a single rupee for this. My education, I did it for free. In a private university, one of the best labs in India, I did education for free. I was given a scholarship by an organization in the US, which gave it to, I was one of the 78 people around the world to get that. Okay. And in my early days, I was not a good student. I was a good student doing engineering. During later on is when I developed and I realized this, that the only thing that differentiates an average student from extraordinary student is the 10%. That's all. How many of you all went through the portion that we did in the last 2 classes? 1 person, 2, 3, 4. But we are not there. Right? It is our job to do it. And the thing is, it's not working hard. You don't have to work hard. You have to work smartly. If today the portion is done, it's still fresh in air, it's very hot. Sorry, what to do? There's no other option. Yeah. So the only thing is you have to work smart. For example, if the class is done, if you want to go to the washroom and all, you can feel free to go. Okay. There's you don't have to tell me and all. Yeah, if anybody wants to use anyway, you can. So what I was saying now? Whatever I was saying. So if the classes are done, the things are fresh in your mind. Go home, try to revise because it's fresh. Anyway, 1 week later you open it, it is going to be like what the heck was this? What this is not. At that time, if it's fresh, you go through it, you are limited. Okay. You guys need a 5-minute break? Yeah. Okay, take a break. You want to wash your face. Start. Yeah, please. Okay. So we are going to do one more teaching. That is not running on set. Last master, there's another washroom at the without the lighting, we can watch light. It's fine. You can use the watch. Regardless, let's do this. We have to do this. Okay. As sweaty as we are, we have to do it. You know how they the first rocket that India launched at that time there was no ISRO, but but at that time I do this so that you guys can. So when they built the first rocket, there was some problem with the labor. You know, the rocket was horizontal and the rocket has to be like this to fly, right? So there was no labor which is pulling it up like this. It was on remote control. And these people, it was the early days. That was quite. Now, Vikram Sarabhai, you for the Sarabhai, it was chairman of the Indian Space Research Organization. So they called the press from US and everywhere around the world. People are there, you know, listening. I know it's not, but my point is this: that the press from around the world was there, and they have a problem. The rocket, the lever which is supposed to do this, is not doing that. The rocket is like this, and unless it stands straight, they cannot launch it. So you know what these people do? They break out. They don't know what to do. Everybody is there. Otherwise, it's going to be public embarrassment around the world. And it is, if they launch the rocket, they will be the only country in Asia or something at that time to have launched the rocket of their own. So it is a matter of great pride. So you know this guy, never came in there. They tie the ropes to the rocket and they hold it. Then it will stand. Okay. So the point is this: no matter how hard the situation is, sometimes when we have to do something, we have to do it. It is not today, it is waiting, but we have to do this. We have to do physics. Okay. So, okay. Can you give me your textbook for a bit? So we have some problems that I would like to solve today based on what we did in the last two classes. You can take some help from your textbook. And there's also some theoretical part, some explanation part which I have to do. So which one do you want me to do first? The explanation part. You hate solving problems. Okay. We'll do the explanation. Just some things. Okay. So this thing in the effect scattering of light. Sun coming. Okay. Alright. So last time we discussed that light, which is white, is not really white. Okay. It is made up of constituent colors or something we call wavelengths. Okay. Wavelength is the word. When you are seeing white color light, no, that is actually not white in color. It is made up of 7 colors. And they are mixing together to make it look like it is bright. Okay, but it's not really bright. So you can separate these colors by using some sort of a prism and things like that. Okay, I have explained this in detail in the last class. I am not going to explain that again. But I will continue the same philosophy and we will do some discussion based on that. Okay. So we have also discussed. So one of the things that happens is I think we can talk about the diffraction, we talk about later. So one of the things that happens is now light will come. Okay. Now see, this is light is the wave. You understand that? Yeah. So this is the wave, or this is the white color light wave. It is made up of 7 different colors. Each of these colors have something called a different wavelength. Getting it? Meaning, this is one wave, okay? Wavelength means length of one wave. That's all. Wavelength. Meaning, one color, one particular color, we start from ultraviolet. So that has the shortest wavelength. So ultraviolet will have the wavelength which is quite short. You're getting the distance between from violet to one wave. This is quite small when compared to that. Okay, this is our, let's say we start from blue. Blue has a smaller wavelength. So like that, another color will have a slightly bigger wavelength, and out of that we come to 7 colors. The last color will be red, which has the widest wavelength. Means length of one wave is very long. Okay, is this much clear here? Have we understood this, bro? Okay, so this is red. Okay, so what happens is when the sunlight comes from the sun, right? The color of the light is actually white in color. Okay, but what will happen? This white light, when it enters our atmosphere contains small particles, and all of that, which are according to the size of the wavelength of blue. Are you understanding? So the blue part of the light will scatter. Meaning, now particle is this is some particle in air, okay? Somewhere up in the atmosphere. Some atoms, some molecules. This light will come like this. It is made up of 7. So let's say this is the red. Red will pass through without being reflected. Blue is of the same size. It will get this and it will reflect or it will scatter. Okay, this is much clear. So the bigger wavelength part of the light, it will pass through. The small wavelength part of it will scatter. So that's why our sky appears to be blue. It is not really blue. Sky does not have a color. You can sky have a color. Right? It's just air with some particles. Okay, you are understanding. So which light is passing through? Red is passing through. So that's why when you see from the earth, you look at the sun, what color does the sun appear to be? It appears to be orangish, it appears to be reddish. Towards the red side, correct? Because the colors toward the blue side are scattered. Blue, violet, and those kinds of things. Okay? Is that much clear to you? But you must have seen something very strange during the morning and during the noon, if you look at the sun. And that is, during the morning, the sun appears to be quite red, and during the noon, the sun appears to be quite whitish. Right? So, what is the reason for this? The reason is quite simply this: that if this is the Earth, and this is the atmosphere, and you guys are here. Okay? Let's say. And the sun is our here during the day. So the light comes like this, okay? During the noon, the light comes like this. So this is during, let's say, what, 7 a.m. simply. Let's say this is at 12 noon. So in which of these cases light is passing through more of the atmosphere? 7 a.m. Correct, no? So what is happening is white light is going from here, it will interact with particles in the atmosphere, blue will scatter. Again, it will pass, whatever remaining blue is there, it will scatter. This process will continue till it reaches the here, till all the blue light has scattered. Anything around the blue side has scattered away. So what is remaining? You know, a good red part is remaining. So when you look at the sun, it appears to be red.
What about ours?
Now what happened? So everything in between is a combination of that. If you look at the rainbow, it's what big gyre, or it's called violet. Indigo also looks like that. B is blue. G stands for green. Gyre, G, Y stands for yellow. O stands for orange. R stands for red. So the only color in between is green, which does not fall into this. But that is a combination of these two. Okay. So when if you actually mix blue and red, you get green, something of that sort, right? It gives out purples, and I think the red and yellow and orange. No. Light blue with yellow, it gives greenish. No? Okay, but it's a combination of these two colors, where around these two spectrums. Correct? You can search and look into this. Okay. So what happens in the moon is, the amount of interaction that light has with the atmosphere is very less. So maybe there is a chance that a little bit of this blue is still remaining, and the sun appears to be quite, all of those colors are quite intact. Okay, this scattering is quite less. Okay, so this is one of the things that I have to cover, and I have to tell you about this.
This light is long. This light long.
It's a transverse wave. Yeah, because it's so you guys know what transverse waves. So light is a transverse wave because its vibration. See, its vibration is like this. So the vibration is perpendicular to the direction of propagation. What happened? Did I mix up the word? What?
And the light reflects. It reflects on like the atmosphere. It's like not.
So this is not the process of reflection. This is the process of scattering. It's the indirect process. Okay. So here it's literally the wave is being picked up somewhere else. It does not follow the law of reflection, incidence, and it is quite random. It can happen in any direction. Because the thing is, the particle size almost matches the size of the wave of the light. The particle might be going in this way. It's like one crazy person jumping out here. You know, it's like literally playing cricket. The ball will come, the particle comes in it is quite random. It may be in any direction. Okay, the process is nothing like it. It's scattered. Okay, so what we're talking about is the transfer. Vibration, sound waves are longitudinal. So the direction you use to vibrate is this way, and it passes on. The direction is parallel to the direction of propagation. Okay, this much clear? Let's see. Okay, does not work. Guys, you can tell things a little louder. We don't have to shy away. Okay, we have to finish this. Come on, quickly. And also, another interesting thing is you The twinkling of the stars. Do you know why stars twinkle? Simply guess. But look right. Okay, you're my new favorite. Okay. What happened, man? Come on, we have things to finish. He said, he said something that absorbed and was sitting on okay. So what will happen is, see, you heard about refraction now. When light moves from rarer to denser medium, distance, so the light will shift towards the north. Okay, the light is moving from rarer to denser medium. If the light is going like this, it will move towards the north. Okay, so light from star comes, let's say, like this. And let's move the star here in the middle. It's coming like this. It's interacting with something in the atmosphere, let's say clouds or something, somewhere it's quite thick, the atmosphere. It moves slightly towards the north and it's continuing. Again, it interacts with cloud or something in the atmosphere which is quite dense, denser than before. It moves towards the north. Eventually, this movement will be in such a way that the person will see the star like this. But the thing is, when we see things in the straight line, and we assume that the star is here. Is that clear? Okay. But the star's original position is there. And see, what I've drawn here is refraction very clearly in 2 points, but it's not that way. In the sky, the density is gradually changing, and gradually it's a very small. Let's say the changing angle is 0.01 degree, but 0.01 degree keeps on changing eventually, and that adds up to be a very big value. Are you understanding? It's not like here, and in this point something happened. The wedding happened, okay? It gradually happens. Okay. So now what will happen is, in the middle, let's say this cloud or something in the atmosphere, it changes its position. So what will happen? The light will move like this. Because there's no refraction happening. This particular part of the lens is air, right? It will move. And this thing, which was bending again, that bending does not happen, the light moves. So will this fellow still see the star because the light is not going into his eyes? Will you see the star? The light is no longer going into his eyes. The power has changed. So he cannot see the star. So then for that fraction of a second, it appears as if there is no star. And again, the star is there. So that is the twinkling of your stars. The star never really twinkle. How can the star use it? Star is like the sun. It cannot go like, okay, for 2 minutes I turn off and then I turn on and on. Huh? Did you think that was the case? Okay.
The star is round.
Stars?
Round.
It's round. It's a sun. Our sun is a star. It's like the sun. And which of those stars may even have their own planets? Many of them do. Yeah. Mine do, right? What is the time? It's 6, right? I'm going to say that, okay, 6:30. What? Oh man, it's just very hard. It's just so small things we don't have to love. Okay. So a similar thing also happens during sunrise and sunset. You can read this, it's quite basic. The sun will be somewhere here. Light will come like this. But now somehow light has gone into the atmosphere. It will keep moving to the normal. Again, the same thing will happen. It will keep moving to the normal. Eventually, this fellow will see the sun, and he sees the sun to be somewhere here. So according to him, the sunrise has already happened, but actually sun is still alive. It's still not. Yeah. But the speed of revolution, it's quite high, it's not that much. So the thing is, this period does not happen for a long period of time. It's only 2 minutes or 4 minutes. Okay. The textbook in fact mentions the time 2 minutes before this. So because of the speed of revolution, this effect is only there for 2 minutes. Huh? No, we see the sunrise 2 minutes before it has actually risen. That's all. Meaning, we will tell because of the revolution. See, sunrise happens why because of this. That's why the sunrise happens. So actually, the sun, when it comes up here, we say that okay, sun has risen because it has passed the center of this thing, or we have rotated past that point. But you are here, the sun has not yet come here, still it looks like it has passed the point. That is my meaning. Okay, and the same thing happens during sunset also. Sun might have already set. It has gone beyond the central axis, and then, but it still appears to the person as if the sun is still in the sky. Okay, so this is it. This is a very simple explanation. If you get these kinds of questions from 5 months and all, you should get such simple things. You don't be asked for 5 months. Okay, fine. And one more thing that I have told you about the scattering of light, it is also called Tyndall effect. Tyndall effect is a different kind of effect, right? It's not really scattering of light. So what happens is, for example, you remember when you're going to, if you're going to a park or a forest, somewhere between those trees, you will see a ray of light come. Okay, but is it really possible to see a ray of light? How can you see? It should not be possible. But what is happening is the reason you can see a ray of light is because the dust particles in air interact with this light, and what you're seeing is a line of dust or something. Otherwise, light you cannot see. See, this tube light is going on, but can I see the rays of light? No. It's just that the light is passing through a particular place, and there are dust particles, or there are particles which are scattering it. So that you can see the path in which the light is going. Okay, is that much clear to you? And this can even be done in a colloidal solution. Again, beaker, I put some water, I put some kind of a salt or some sort of liquid, and I pass light through it. So the particle size should be big enough. Okay. Then along this path, this particles will shine, and that's why I can see a path. Is that much clear? Okay. Now we will do problems. Problems from the first unit, the previous discussion. I hope you remember the. Yeah, I'll give you the formula, man. He'll give you the formula. Anybody will give you the formula. Okay, just relax. Can have they given you these books or anything?
Yeah.
Okay. Don't open it. My problems are from there. Okay. See, some of the things they are not solved though. Whatever I thought was slightly difficult, we will do. Okay. So, listen. So, you guys remember things we did in the previous classes? For example, concave mirror or any kind of mirror. This, if you remember the sign dimension, along this side it will be correct. Along this side it will be negative. If the height is upwards, if the height is downwards, what is my mirror formula? No, 1 by 1 by v plus or minus. Sure. My f is half total length, but what is it? Half of radius of curvature or center of curvature. Is that clear? Remember this. What is magnification? Minus
Minus
u by v by u. What are you guys saying?
V by
This is equal to the height of image by height of object. With this, we will do everything. Okay? Next we'll come to it. We'll do that in a moment. We first start with mirror, no? Let me give you problem based on this. Why you want to do everything together? Okay. So you guys can okay. Note, do you guys want to know the problem or do you want to see it from the book and do it? Because that will take less time. Okay, anyway, they are not given the answer to that. Okay, open the book, go to page number 12. Your yes. Then okay, clean your books. Yes. Or Mama, you have the book? You have the book? Nobody has the book. Except you. Okay. Fine. Note down the question. The focal length of a concave mirror. Yeah, man, write in your rooms. You should understand this. The focal length of a concave mirror is f. Obviously. That is the question, right? Okay. And the distance from the object to the principal focus. I will give. The focal length of a concave mirror is f. Okay, that's the first line. The focal length of a concave mirror is f. And the distance from the object to the principal focus. The distance from the object to the principal focus is a. Okay. Find the magnitude of magnification. Find the magnitude of magnification. Okay, I repeat the question. Of magnification. I'll repeat the question again. I'll repeat the question. The focal length of a concave mirror is f, and the distance from the object to the principal focus is a. The magnitude of magnification. Find the magnitude of magnification. So there are few options. Okay. Option number 1 is f plus a by f. Option number B is f by a. Option C is root of f by root of a. And option D is f square by a square. Solve it. Anybody getting to right now? It's quite easy. So we have to find n, right? You have to find its magnitude. You will keep equal to this or this or this or this. See. Anybody have any clue how to start it? No problem. We can discuss. It's fine. Do you want me to solve the first part? Do you want me to show you how to do this? Yeah. On the next one. Okay, I don't keep looking at this. So the focal length of a mirror, if f value is going to be f only. But what mirror is this? It's a concave mirror. So will it be plus f or will it be minus f? It's going to be minus f. Always remember your sign convention. Okay. Now what is that? What is going to be the distance? What? Object is. It is distance of object is minus a. Wrong. Read that properly. Unnecessary. The distance from the object to focus is a. So this is my focus. This is my focal length. The distance from my object to the principal focus is a. So what becomes my distance from my object? M. A plus F. But it's minus. So it is going to be, my U is going to be minus A minus. Clear? Okay. So now I know my formula, that's 1 by B. Everybody should tell me now. Okay. So what is my U? Can I write it as minus outside A plus F? Can I write it like that? And my F is going to be minus 10. Correct? I want to, let's keep it this way. Yeah. Correct. But what they have asked me for magnification. In magnification for formula, by U I know, correct? No? What I don't know? So can I find V from here and then put it out here and U I put this out here? That much you guys will come on. Take care of the sides, all the sides you have to include properly. English without parameter mistake. Okay, that is figure it out, but you got to know how to do this. Have you understood? Is this much clear to you? This one, no? Yeah, this one. Okay, so I have continued the math here, and what you do is when you have 1 by f plus 1 by this one, you don't have a common denominator, right? So you know that you have to multiply this one by this denominator. You guys know that concept? Okay, let me go. Now I have 1 by, let's say, a plus 1 by b. Okay, I wanted to give one proper term. So I multiply 1 by a into b by b, and I multiply 1 by b into a by a. You guys know this? You might have the cross multiplication line. So you guys have b by ab plus a by again ab. So we are the same thing. The reason this is done is so that you guys have one common denominator and you can write it as one proper term. Same thing happened done here. Okay. I multiplied 1 by f here and here. Okay. And I multiplied f into numerator and denominator. The denominator will be common. This will be 1 minus 1 by f plus f. So the minus goes into here and here. So it will be minus f plus f. Minus will be minus f plus f will get cancelled. Now minus a by the same. Okay. Then I take the reciprocal ulta. Ulta. And then I put r here. Okay. And you have this is here, right? It's very simple. What do you think? Is this direct? You're putting here so that there's okay. So what is the correct answer? It's f by a. Somewhere I have done one something, just figure it out. It's not that difficult. Right now we are short on time. So I want to give you, but you understood method, no? Method you understood. Okay, can I erase this? Okay. Okay. So what? Let's do one more problem. Okay. A 2 centimeter long object is placed perpendicular to the principal axis of the concave mirror. Okay, I repeat the sentence. A 2 centimeter long object is placed perpendicular to the principal axis of a concave mirror. Okay, next line. The distance of the object from the mirror, is 30 centimeter. And its image from the mirror is 30 centimeter. And its image is formed 60 centimeter from the mirror on the same side. I repeat, the distance of the object from the mirror is 30 centimeter and its image is formed 60 centimeter from the mirror on the same side. On the same side of the mirror as the object. On the same side of the mirror as the object. Later. Okay. So the question is find the height of the image. Find the height of the image. It starts over. First job always the best thing that you can do is note down what are the things which are given to you, the values. Okay. So what is given? The height of the object is given. What is the height? So write that. Is that going to be u or v? U. U is equal to 2 centimeter. So it's perpendicular, so it's standing. So it's plus 2 centimeter. What else is given? Distance of the object from the mirror. So what is that going to be? Sorry, the height of the object is not v or v, it is h. It is the 2 centimeter long object. That is the height of the object. That is h. Is it not h? Yeah. So what is given? 30 centimeter. What is 30 centimeter? That is u. So that will be plus or minus? Yes. And the image is formed. So what do you have over there? What is that? From the mirror. So it is distance, no? What is 60 centimeter? No, correct, that's feet. Right. V is equal to 60 centimeter. It is on the same side, so it is plus or minus. Minus, correct. Okay. So what do you have over here? You have u, you have v, and you have h. And what do you have to find? H. So do you know any formula in which u is there, v is there, h and h dash is there? Magnification. That is not necessary. We don't have focal length. We can find a focal length. And then we can, but that is again necessary. You can find a focal length. So, m is equal to minus v by is equal to h dash. Okay. So this you know, can you find magnification? Yes. This value is going to be equal to h dash by h. Can you find h dash? Yes. Come on. For magnification. Magnification will be magnification does not have very simple. Minus 2. Minus 2. Minus 2. Okay. The height of the gauge will be. That is minus. So one minus this. Where the positive your mark. No. Minus. It will be minus of minus. Minus of minus will become. And it is also minus the rate of minus. Minus and minus will become plus. Okay, so it will be plus. This out and so I'm going to minus two. Strong value what is it strong? Strong. Everything clear? That's anything was on. Yeah. Okay. Understood? Here. And we do one more problem to figure some things out of the time. I will do the question for you. But yes, you can. You have to go home or you have to do it at home? You want to do it at home. You're very dedicated. You guys agree with the decision. You guys want to we will try and finish some things before the assembly. So what did we discuss about power last week? Okay. So there is a quantity called power. Power is equal to 1 by F. Okay. F is your total length. Power is going to be 1 by F. That's all. And the SI unit for power is that. The one you asked me last time. It's aeronautics. What is this? Depends. We use what actually? DIOPTRE. The highest power which is ever achieved was the power stimulation square. This is the highest number that has ever been achieved with the tables and the not identified the square. Just understand this, that 1 watt is very huge. Okay, then about 22 watt means after 1, I'm going to put how many zeros? 22 zeros. That many watts in how much? In 1 centimeter square of space. Okay, this is what I think they have calculated this. They say about 1/10 per power of the sun. Fine. But here they usually refer diopter. Okay. Okay. One way focal length, and this very important. Focal length has to be in meters. So whatever your values are in centimeter, you have to convert it in meters. If you don't, answer is wrong. Okay. So quickly, if you have understood this, quickly we will go on to problem. Based on this, we will go on to problem. Let's see. Okay. So write this. The focal length of the lens. Focal length of the lens is 50 centimeter. What is the power? That's all. That's why I can do it. 0.5. 50 centimeters, 50 into 10 to the power minus 2. And minus 2 into like this, and you go 0.5 meter. So 1 by 0.5. And 0.5 is 1 by 2, so it becomes 2. Solve. Or the easiest way for you guys to do 1 by 0.5 is multiplied into 10. So this will be 10 by 5. 1 by 2. I have this is wrong. Very important. If you want, I can finish. If you want, I can continue. So, power cut issue. Yeah, that's back.
Sorry guys. You're getting roasted. Will you be able to reach that point? Can you press that? Can you long press that with the remote?
So,
The power button, yeah. That's right. Let's wait for.
one minute, the thing is. Okay. A student needs a lens of power. A student needs a lens of power minus 2 diopter. Diopter is right minus 1 minus 2. you should understand that. Okay. To correct his vision. Is the focal length of his lens. What should be the focal length of his lens? Hmm. This is the one where but it's in the same. And that will come up. Two will come down. It will be one minus one by two. One and one and one. Some. What is my value? Minus. Two. Okay. So one by. Come on this side. So this numerator should go. No, it doesn't. Let's see. So listen, if this will come here, your numerator will always go to the other side denominator. Understood? No? So one will go to the other side, it will come down. Two will go up. This has to come here. Three will come down. Four will go. The meaning is the same. If I make it full time, it will be two by 4 equal to 1 by 2. It's the same as this is maths. This is maths. I don't know. If I have to teach you 8 standards and then maths and all, I'll give that I don't know where we will reach. F will come up, we go down. All you can do is you can do the ulta, flip it. So I flip this. F will I bring up is equal to 1. Understood? This way you have understood this? So this will be 1 by 2 is not. 1 by 2 is half. Half is 0.5. Okay? 1 is simple. These are very simple laws. But 0.5 what? Or F should be. So this is the 0.5 meters. Can you convert this to centimeter and let me know? How many centimeters will this be? 50 centimeters. Minus. Any doubt? How to do plus minus and all? I'm sorry, I just like. Okay. You want to be done or you want to do one last topic? Let's and then we are completely done with the unit. Can you I'm not know that you again, but see, there are also questions that I wanted to solve today. But because of the lab time, I'm doing different types of problems, more than difficult ones of the same. If you write it, okay, you can be more than one. Okay. A 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens. Okay. A 2 centimeter tall object is placed perpendicular to the principal axis of the convex lens of focal length 10 centimeter. Convex lens of focal length 10 centimeter. Okay. This much did you guys write? The distance of the object from the lens. The distance of the object from the lens is 15 centimeter. Find the nature, position, size of the image. Find nature, position, size, and magnification of the image. Nature, size, position, magnification of the image. Okay. So, what are we dealing with here? Okay. So, what do we have here? What is the F? Plus or minus? So the thing about lenses is, for a convex lens, F is positive. For a concave lens, F is negative. The idea is this: if the object is up here, it interacts with this surface. Is everybody seeing? If the object is on my left side, okay, and you will see if my object is on the left side, it is two surfaces are there, A and B. Which surface is interacting with first? A. So the A focal length is on which side? This is circle, right? So the focal length of the focus is on this side. So it is going to be positive. Here. Here. And here it's interacting, object is on the side, it's interacting with the surface, the A. The A forms a circle, and its focal will be on the side. Negative side. If you imagine that, everything is very easy. Okay? So can you just solve it? Come on. If there's no formula here, then that's the formula. One by B. Minus or plus? Minus or plus? Is it equal to 1 by? The first law will be to find E. Actually, no, it's dash should be get minus. Guys, listen to me. Listen to me. Whenever you have to solve a problem, first law you're going to write whatever you have. Okay. Second law is always to write whatever the formula you know. So when you look at the formula and you look at this, you say, okay, I have F also I have. What I don't have? P. So can you find that? Then you will see. Then you write the formula of magnification. And you say that I know U also, I know P also. I can find magnification minus. It will again it will be plus. U by U for lens. Similarly, now if I know magnification, I know magnification is also equal to H dash by H. And H value I have. And find H dash. This one by 10. Yes. 1 by. Okay. Let's forget there is no minus. How many of you guys know how to solve this? You know how to solve this? This one, man. No, okay, listen. Many have a situation like this. See, the idea is